Hey, welcome back. I'm Caleb with Timpson, and today we're going to talk about inductance. And I got some stuff set up here. We're going to do some experiments that you can do in your class, whether it's transformers or a grounding and bonding class. It's a fun little experiment to get the guys involved and to open some eyes up. And what I got set up here is I got a coil of speaker wire, and I got this hooked up to this variac, and right now I got both of these legs paralleled, and I'm going to apply a little bit of voltage and current to it. And on the other one, I got another coil of speaker wire, and on these I hooked them up in series. So we're going to get a little bit of a higher voltage, and we're going to set this one on top of that one and pump some current into it and see what happens. So you'll watch this light bulb will come on just barely, and you can see that light bulb come on. But what's cool is you got your magnetic flux, your inductance inducing a current into this coil. But if I put a core in there, like this piece of pipe, that light's going to get a lot brighter. And we can actually take this coil and lift up and get some good separation between there. And you can still see that light lighting up. And if we take this amp probe and we read the current on the line, all right, so we're looking at about, let me turn that down a little bit, 18 amps. If I pull this out of there, you'll watch that current go up. So we've gained an amp. And what's cool about this, if you leave this in here long enough, you actually start getting no load losses inside of this piece of steel, also known as eddy currents or hysteresis. And eddy currents is how an inductive stove works. One of those stoves that has the coils, you set the pan on top. The top of the stove doesn't get hot, but the pan heats up. Eddy currents and hysteresis are why we have to have laminated cores in our transformers. So as the current and the magnetic flux cuts through that mass of steel, it's able to do it without having those losses. So if I pull this out and I feel this is actually pretty warm to the touch. And if I left that in there long enough, it would get much, much hotter. So another way we can do a test with inductance is using this piece of equipment here. And this is a Barometers GT400, and it's a grounds tester. And this tester is pretty incredible, not only for testing your grounds, but being able to do some cool experiments during class. Showing why we wouldn't put loops in a mechanical jumper, or why we're not going to coil our grounds up and hang it on a bolt sticking off of a structure. And as we talked about before, eddy currents create friction within, and that causes heat, which ruins the integrity of the wire and reduces its current carrying abilities. So what I got here is a regular ground, and I've put 2 coils in it. And we're going to crank this up to some current. And I'll crank that up to about, I'll say, 350 amps or so. And you can see I got a voltage drop of about 0.5 volts. Now, 350 amps is too much for this ground, especially with coils in it. But if I take this coil of wire and I stick in the middle of here, you'll see that I can get that light to come on. And the same, if I take the bolt and I stick through the center of it, that light's going to get brighter. So this is a good way to show how inductance, or not only capacitive coupling, but electromagnetic coupling can and will induce a current into an adjacent line, say in a transmission right-of-way or something like that. So it's a good experiment to do. It's fun, and we can also take a handful of magnets, and if you get your trainees to put them in their hand and they start sticking their hand down towards the middle of that loop, you can feel these magnets vibrating. And in fact, if I set this in the middle of the table, you can see the effect there. Now what's even more interesting is if I lower the current here, let me lower that to about 200 amps. So we're about 200, 193. If I start uncoiling this wire and we pay attention to that current, as I uncoil it, you'll see that that current actually increased from 193 to 220 230 amps. If I put those loops back in there, it's now reduced again, showing you that putting coils in any type of wire reduces its ability to carry current and furthermore fault current. So when we are doing a wire pull job and we have a mechanical jumper up in the air that we're going to leave and say it's a little bit too long, how many of us have put 2 or 3 turns in that and taped it up to the line? Right, and what we're doing is we're making a big ball of inductance there. And if we make that ball of inductance, depending on how much current we have running through that line, we're going to get that light delayed up. Right? Again, this is a Barometers GT400. They make a 600. This is a great piece of equipment to not only test the grounds, but do some pretty cool experiments. The longer the ground you have here, the more you can do with it.